This is section 4.2, part 1, where we're going to look at graphing quadratics. And if you remember back in section 4.1, we graphed quadratics as well, and we graphed them in standard form. Here in 4.2, we're going to begin by looking at quadratics in vertex form. So what does vertex form look like? Well, the formula that we should know is y equals a times the quantity x minus h squared plus k. All right, we want to know that form. And in standard form, sometimes we had to find the vertex. It wasn't easily identifiable. So we had to first find our axis of symmetry, which was x equals the opposite of b over 2a. Found the x value, plugged in the equation, then we found our y. So there's a little bit of work. With the vertex form, it's much, much easier to find the vertex because the vertex is identifiable in this form. What is the vertex? The vertex will hold the value h, k. So just when we're in this form, we can look at h and k. K will always hold the same value as the number in the equation. H will always be the opposite value of what you see in the equation. So let's take a look at that. All right, let's come down to our first problem, number 1, where we have y equals 2 times the quantity x minus 1 squared plus 3. So I've got 2 stars below that. We're going to point out 2 pieces of information here. All right, the first thing we want to point out is, well, let's find the vertex. All right, we see it's in vertex form. So what is our vertex? Remember, the vertex is h, k, where h is this number, k is this number. We know h is going to be the opposite of what we see here. So since it's minus 1, this is going to be positive 1. This takes the same value, positive 3. There's your vertex. The second thing I want to point out is the value of my a. You always want to analyze that a value, that number, because that's going to tell you whether your parabola opens up or down. You should be able to identify that without even graphing. So what do we notice about that a value? It's positive. So if a positive a value tells us our parabola, our graph is going to open up. It's going to open up because the a value is positive. If it were negative, we would expect our graph to open down. So next up, we want to start populating our table. And if you remember from section 4.1, your vertex still always goes right in the center of your table. This is where our vertex is going to go. And we found our vertex. Our vertex is 1, 3. That's important because that's going to help us pick our 2 numbers on one side of the vertex as well as the other. Remember, these 2 numbers should be the same distance away from the vertex. So from 1, I'm going to go up to 2. So we can see that's 1 unit apart. So I'm going to go down to 0. Also 1 unit. So I'll go up to 3. These are 2 units apart. So I'm going to go down to -1, which is also 2 units. And then lastly, to find the y values, we simply do a little bit of mental math. Plug the value of x in. So I'll plug in 0 first. 0 minus 1 is -1. -1 squared is positive 1. Positive 1 times 2 is 2. 2 plus 3, that gives me 5. Then I'll plug in -1. -1 minus 1 is -2. -2 squared is positive 4. 4 times 2 is 8. 8 plus 3 is 11. And if you remember from 4.1, these numbers should match. If these 2 numbers are equidistant, which they are from the vertex, these 2 numbers will match. And if these other 2 numbers are equidistant from the vertex, and they're both 2 units away, these 2 y values should match. And they do. So we can throw 3 in here just as a quick test. 3 minus 1 is 2. 2 squared is 4. 4 times 2 is 8. And 8 plus 3 is 11. All right, so it matches up. So the last thing I need to do is plot these points. So I'm going to first plot my vertex. I like to plot that first. So 1, 3. Notice my x values go by 1s. My y values go by 2. So I'm up 2. Halfway up is 3. Then I'm going to go to 2, 5. So 2, 2, 4, halfway up. It's about 5. And then 3, 11. So 2, 4, 6, 8, 10, halfway up. About right there is 11. Then I'm going to plot 0, 0, 5. So 2, 4, halfway up is 5. Plot it in the wrong spot at first. And then -1, 11. We can draw a smooth curve, passing through the points, smooth as possible. I don't have the steadiest hand, so my curve probably won't be as pretty as yours, but generally that's the gist. Remember, there's an imaginary line which passes through the vertex. What is that imaginary line called? That's called the axis of symmetry, and it holds the value of x equals 1. So if the problem asks you to label the axis of symmetry, this is simply all you have to do. Draw a little dotted line which shows the imaginary line passing through the vertex, and then I label it x equals 1. And your axis of symmetry is always going to be the x value of your vertex. Notice my vertex is 1, 3. My axis of symmetry is x equals 1. Alright, and that's part 1.